Hello everyone, my name is Li Yiling. Student ID is 146384110. In this video, I will introduce the region recipher using my assessment ciphertext as a case study. I will briefly cover its history, how it works, and how I cracked the given ciphertext, then finish with its strengths, weaknesses, and modern relevance. Here is the outline of my tutorial. First, a short historical background of the region recipher. Second, how it encodes and decodes using a repeating keyword. Third, a step-by-step cryptanalysis of the assessment ciphertext, estimating the key length, recovering the key, and checking the plaintext. Finally, I will summarize strengths and weaknesses, discuss use cases and modern relevance, and briefly mention legal and ethical issues in cryptography. The region recipher appeared in the 16th century as a polyalphabetic substitution cipher. Instead of one fixed shift like Caesar, it uses a keyword to change the shift for each letter. So it was once nicknamed the indecipherable cipher and used for diplomatic and military messages. In 1863, Friedrich Kaspersky showed how repeated partners and their distance can reveal the key length. In the 1920s, William F. Friedman introduced the index of coincidence, a statistical tool to estimate the key period, helping to formalize modern cryptanalysis. The region cipher maps letters to numbers from 0 to 25. We choose a keyword, for example, classical, and repeat it under the plaintext, so every plaintext letter has a matching key letter. To encrypt, we add the plaintext number and key number and wrap around within 0 to 25, then convert back to a letter. To decrypt, we take the ciphertext number, subtract the key number, and turn the result back into the plaintext letter. The table on this slide shows a short example where you can see the plaintext, the repeated key, and the resulting ciphertext for a few positions. In this time, Regioner has several strengths. It is polyalphabetic, so single letter frequencies are much better hidden than in a simple Caesar cipher. It is easy to use by hand with paper, a table, and a short keyword. With a very long, non-repeating key, it behaves similar to one-time pad in theory. But from a modern view, it has clear weaknesses. People usually use short repeating keys, which create strong periodic patterns that leak the key length. It is vulnerable to statistical attacks such as index of coincidence, Kaspersky's method, and chi-square tasks. It also only provides confidentiality and not integrate or authentication. Now I will explain how I find the key length for the assessment ciphertext. The ciphertext has 854 letters clean to lowercase without spaces and punctuation. I start with the fragment text, using the overall index of coincidence. The value lies between typical English and random text. And Friedman's method suggests a key length of about 9 to 10. To confirm this, I run an average column IC scan. For each candidate key length from 1 to 20, I split the text into that many columns and compute the IC for each column. Then take the average. On the plot, the most key length looks like random, but k equals to 9 and k equals to 18 gives clear peaks, meaning the columns start to resume English. Then I perform a Kaspersky examinations, find repeated sequences of length 3 to 6, measure the distances between them and factor those distances. Factors 3, 9, and 18 occur very often, as shown in the histogram. Since both methods highlight 9 and its multiple 18, so I choose key length 9 for this ciphertext. With the key length fixed as 9, I move to recover the key and the plaintext. I split the ciphertext into 9 columns, one for each key position. Each columns behave like a Caesar cipher on English, because the same key letter is applied repeatedly. For each column, I try all 26 shifts. For every shift, I compare the resulting letter frequencies to standard English to compute a chi-square score. On the slide, you can see example curves. The lowest point on each curve gives the best shift, and therefore the key letters on that value, on that column. Repeating this for all 9 columns, the letter for key is classical. Using the key, I decrypt the whole ciphertext by subtracting the key letter at each position and converting the result back to letter. The final plaintext is fluent English from start to finish. The small decryption trace on the slide shows the first few positions: ciphertext, key letter, shift, and plaintext, conforming a stable 9-letter cycle. My Python script automates these steps and exports the plots, tables, and text files as evidence that the description is correct. Historically, from the 6th to 19th centuries, 60s to 19th centuries, the vision receiver was used by diplomatic, military, and private communication. It was popular because it could be done entirely by hand with a short keyword and a table, and it was stronger than simple substitution. Today, it is not used for real security, but it is very common in education, CDF challenges, and puzzle games. Working with regioners helps students practice frequency analyze, key management, and the risks of key reuse, and understand the idea of combining a key stream with plaintext. They connected directly to modern stream ciphers, which also makes a key-dependent stream with a message, but at the bit level. Cryptography is not only technical, it also has legal and ethical sides. Encryption protects personal and business data, and many privacy laws expect organizations to use it properly. Breaking ciphers should only be done with permission and within the law. Attacking real systems or leaking decrypted data can be illegal. To conclude, I briefly summarize the tutorial. I introduced the Vision Receiver, its history, and how it encrypts and decrypts with a repeating keyword. I then show a full attack on the assessment ciphertext using the fragment text test and column IC plus cassette key to find key length 9, and chi-square on each column to recover the key classical and fluent plaintext. The the asterisk had how repeating key classical cipher can be broken by statistical analysis and how ideas from regional help us understand modern stream ciphers and real-world encryptions together to illegal and ethical responsibility. Thanks you for watching my presentation. That's all.